Hi everyone. We spent the past couple days or the past couple lessons just talking about angles, like radians and degrees and some different important things about angles. Now we're ready to start actually talking about trig or trigonometry. So let's start with a definition. Trigonometry means the study of triangles. So anytime you're doing trig or trigonometry, you're talking about triangles. Now there are 6 trig functions that we want to know. For each one, I'm going to give you the full name and then the 3-letter abbreviation we usually use. So the first one is sine. The actual word itself is spelled S-I-N-E, but we usually write S-I-N in equations, and that's like the button you'll see on the calculator. Then you have cosine, and that would be C-O-S. You have tangent, T-A-N. Those are your 3 main trig functions. You have secant, which is S-E-C. You have cosecant. This one's a little tricky. This is the only one where the 3 letters aren't the first 3 of the word, and that's because the first 3 are COS, and we already used that for cosine. So be careful with that. Cosecant is CSC. And then we have cotangent. So the other 5 are easy to remember. The abbreviation is just the first 3 letters. All right, now what a trig function does is it describes a ratio or a fraction of side lengths of a right triangle. So you guys probably remember the little memory trick. Sometimes I call it a word. It's not a word, but it's a memory trick. SOHCAHTOA, S-O-H-C-A-H-T-O-A. And that helps you remember the 3 trig functions and the ratio of side lengths that it describes. So each letter in SOHCAHTOA stands for something very specific. Let's go over that right now. The S from the SOH part, from SO, stands for sine. The C is cosine. The T is tangent. So for each group of 3 letters, the first letter is a trig function, sine, cosine, or tangent. Now the rest of the letters, the O's, the H's, and the A's, give you the ratios. So O stands for opposite, A stands for adjacent, and H stands for hypotenuse. So basically in SOHCAHTOA, the way it works is each group of letters, like S stands for sine, OH is a fraction or a ratio. O over H would mean opposite over hypotenuse. This is a ratio right here, A over H. That would be adjacent over hypotenuse. O over A, that's opposite over adjacent. So basically, we got to make sure we really understand what those 3 things are, opposite, adjacent, and hypotenuse. So if you look at a right triangle, I'm going to draw one out here. Let's say I have a right triangle, and we'll say this is my right angle right here. Now, of the 3 sides, opposite, adjacent, and hypotenuse, the easiest one is the hypotenuse, because that never changes. We have one definition of a hypotenuse. The hypotenuse is the side of a right triangle that's opposite the right angle. So since I put the right angle there in the bottom right corner, if I go across or opposite from it, that side right there would be hypotenuse. Now for the other 2 sides, before we get to opposite and adjacent, in a right triangle, the other 2 sides, the 2 sides that are not the hypotenuse, are both called legs. But we need to be more specific because if I just say leg, you don't know which one I'm talking about. And that's where opposite and adjacent come into. So basically when you're doing trig, every trig question, you have to be talking about an angle. So you have your right angle. We're not going to use that one. Of the other 2 angles in the triangle, you need to be talking about one of them. So let's say in my problem, this is angle theta right here. That would make this side over here the opposite leg. Because that's what we mean, is opposite from the angle that you're using in the question. And that would make the bottom side the adjacent leg. Because the word adjacent means next to or connected to, and see how it's connected to theta, or it's next to theta? Now, It's different for every picture. If I change the triangle and draw it in a different way, or let's say in a different problem, I'm talking about this angle up here. Let's say I talk about alpha. I'll call it alpha. If I'm using alpha in a problem, then the bottom leg is opposite because it's opposite from alpha. And the right-hand one is adjacent because it's adjacent or connected to alpha. So just be careful with opposite and adjacent. Make sure if you don't have the opposite and adjacent labeled correctly, then none of the rest of the work is going to matter. Okay, so here's how it breaks down. I kind of already said this. I'll put them all up here. SOH would be sine of, I put theta in here, but whatever angle is in the question. Sine of theta equals opposite over hypotenuse, SOH. And then CAH, cosine of theta is adjacent over hypotenuse. TOA, tangent of theta is opposite over adjacent. So that's how SOHCAHTOA helps you remember. Each group of 3 letters is a ratio. The first letter is the name of the trig function, and then it's second letter over third letter. Opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. Now here's an important thing. A trig function by itself is meaningless. You can't just say sine. It has to be sine of something. You can't just say tangent. It has to be tangent of something. So for example, I said never just write sine equals 1 or cosine equals x. Those are incomplete statements and they don't mean anything. When I read that, I say sine of what equals 1 or cosine of what equals x. So you have to take a trig function of an angle. So you can say things like sine of theta equals 1 or tangent of 60 equals radical 3. Those are both fine, but you got to have an angle coming after your trig function. And one way I like to explain it is this. If I said x plus equals 10 and asked you to solve for x, you guys would immediately notice something's missing. You'd say x plus what equals 10? Because it's just missing something. Well, that's the exact same as what you see up here. When I say sine equals 1, it's missing something. It needs to say sine of something equals 1. Okay, so we did have 3 other trig functions. I call them the other 3, but each one is actually just a reciprocal of one of the main 3. So what you want to do is just remember which one goes with which. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. And it's literally just a reciprocal. So if sine equals 2/3 or 2 over 3, then cosecant equals 3 over 2. Just flip the answer and you got the other one. Now the other main tool that you want to remember for right triangle trig, which was the title of this section, is Pythagorean theorem. So when it comes down to basic fundamental trigonometry, your 2 main tools are SOHCAHTOA and Pythagorean theorem. Now, Pythagorean theorem is if you know 2 sides of a right triangle and you want to use it to find the third one. And it's a very familiar, probably, and simple equation. I'm sure you guys have used it several times before. A squared plus b squared equals c squared. C has to be the hypotenuse. A and b are the legs in either order. So a squared plus b squared equals c squared can always be used to find the third side of a right triangle if you know 2 of them. So what we're going to do for today is we're going to solve triangles. We're going to find missing pieces from triangles. Now, one way to do it we just talked about, Pythagorean theorem. Another way is SOHCAHTOA. So let's focus on the SOHCAHTOA part here. You can use these trig ratios or trig functions to find missing pieces of a triangle. So basically what you want to do is, first of all, if it's not already there, a lot of times it is in the question. If it's not already there, assign a variable to the missing piece. Say, okay, I'm trying to find this side of the triangle, let's call it x. Or I'm trying to find this angle, let's call it theta, whatever you want to call it. Then you want to choose the correct ratio based on what's given in the question. And that's where you want to be real careful with SOHCAHTOA. There's usually only one you can use. Like in a certain triangle, I can use sine to find that missing side, but cosine and tangent wouldn't help me. or one of the three. Then you set up the ratio using SOHCAHTOA, and then you solve for x, or whatever you called your variable. So let's try this one out right here. Here is a right triangle. I gave you one of the sides, the side BC is 11. I asked you to find the bottom, side AC, that's x, and I gave you one angle, that's 37. So this is not a Pythagorean theorem question. That's the first thing I want you guys to notice. In order to use Pythagorean theorem, you have to know two sides, and we only know one. So let's try SOHCAHTOA. And if I'm going to use SOHCAHTOA, the first thing I'm going to do is I'm going to label the sides. So I see angle C is the right angle. If I go opposite it, that makes this side the hypotenuse. Then I notice this 37-degree angle right here, angle B, that's the angle that we are using in this problem. And you got to identify that because that's how you differentiate between opposite and adjacent. So if I'm using angle B, then X is the opposite leg because it's opposite from that 37-degree angle. And then 11 is the adjacent. And that's usually how I think of it, is find hypotenuse, find opposite, and the third side, whatever is left over, is adjacent. But technically adjacent means next to or connected to the 37-degree angle, and it is. Okay, so here's the thing. I look at the question and I say, I want to use the 11 because that was one of the numbers in the question. And I want to use the x because that's what I'm trying to solve for. Well, that's A and O. And if you think about SOHCAHTOA, I'll write it out just this one time. This has to be a tangent question. That's the only one that uses those two, the only one that uses O and A. See, I don't know what the hypotenuse is, so I cannot use H in this problem, which means I can't use sine because that needs an H, and I can't use cosine because that needs an H. So usually based on the information in the question, there's only one that works, and in this case it has to be tangent. So I'm going to set up an equation for tangent. And now this is where, remember, I did a whole slide on this. Don't just write tangent. Don't write tangent equals. It has to be tangent of the angle in the question. And the angle in the question is 37. So it's tangent, we picked our correct trig function, of 37, the angle from the question. And now what it equals, you go back to SOHCAHTOA, it's OA, opposite over adjacent. So that would be opposite is x, and adjacent is 11. Now, to finish solving for x, I can do it in one step. I basically just need to multiply both sides by 11. So I'm going to multiply both sides by 11, cancel that out, and x equals, and this is the part where I would grab a calculator. So you grab your calculator. Now make sure for this question your calculator is in degree mode, because we're going to be going back and forth. And that's an important thing. When we talk about degrees and radians in 9.1, the calculators have both versions, and whatever angle you're typing in, like I'm doing 37 degrees, I need to be in degree mode. So I'm going to double check that. My calculator is in degree mode. And then I'm just going to type 11 tangent 37. And we'll round off our answer. We'll say x is about 8.29. But basically that's how it works. You got to use SOHCAHTOA to choose the right trig function. You set up the trig ratio, and then you solve for x. So we'll do one more example, a word problem one this time. So we have a 20-foot ladder leaning against a wall. The bottom makes a 71-degree angle with the ground. How high up the wall does it reach? So let me draw a picture for this. Let's say here's the ground and here's the wall, and that's going to be our right angle. And then you have this ladder leaning against the wall like this, and that's going to make the triangle. So there's my triangle. It says a 20-foot ladder. So the length of the ladder is 20 feet. The bottom of the ladder makes a 71-degree angle with the ground. That would be right here. how high up the wall does it reach? So that would be right here. I'm going to call that X. And now the question looks almost exactly, it's a ladder picture, but it looks almost exactly like our last one. There's an X in there, there's one side given, and then there's an angle. So let's go ahead and set up to solve. I'm going to label my sides again. The ladder itself is the hypotenuse because it's opposite from the right angle. Since the 71 is down here, basically on the ground, X is opposite because it's opposite from the 71, and then kind of by process of elimination, that side on the bottom is the adjacent. So if you're looking at it, this time I definitely want to use the 20, which is the hypotenuse, and I definitely want to use the X, which is opposite, and for the same reason before, I can't use A. I don't know what A is, and it's not what I'm trying to solve for. So if you look at SOHCAHTOA, I'll do it one more time, where I write it out. I don't usually write it out each time, but since this is our notes. If I want to use the O and the H, I'm using sine. And just like before, remember, I don't know what A is. I can't use cosine because that one needs an A, and I can't use tangent because that one needs an A. So both of those are automatically eliminated. Only one of them works, and it's sine. So once I realize that, I'm going to set up an equation for sine. And I'm going to remember, after I write sine, cosine, or tangent comes the angle. And in this case, it's 71 degrees. And then it equals opposite over hypotenuse. So opposite is X, and hypotenuse is 20. And I can solve in one step again. So if I multiply both sides by 20, to cancel that out, we can just use a calculator for our final answer again. So I go 20 sine of 71, and this one's about 18.9. 18.9 feet. So that ladder, that 20-foot ladder, leaning against the wall, is reaching about 18, almost 19 feet up the wall. But you guys get the idea. What we're doing is we're setting up a triangle, whether it's a picture given in the question or a picture you have to draw yourself like this one. We're identifying opposite, adjacent, and hypotenuse, and then we are using SOHCAHTOA to solve for something in the question, whatever we're asked.